Alright, so that was our discussion on Hadoop so far. The MapReduce, basically the MapReduce as a concept, the various aspects of MapReduce. We try to do MapReduce in another way. In case you were not able to connect so far, you were very comfortable with the idea of MapReduce so far, do not panic. First, you could go through the videos again. Second, even if you are not thorough with Java and all of this programming, you can use languages like Pig, which we are going to cover next. Okay? So what exactly is Pig? It's basically to execute data flow in parallel on Hadoop. Okay? What does it mean? The way earlier when people used to code and for every problem you have to go back to coding and then give the results. But then that was very clumsy and time consuming. So people came up with databases like Oracle and MySQL, MS SQL. So there you can quickly query the data and get the results without having to worry about for loops, while loops, and all that. Right? In the similar way, there are these engines like Pig, which Pig makes it possible to do the same thing for MapReduce. You don't have to write code and it will do the work for you. Okay, it provides you lot of complex operations readily. Uh, okay, so it provides you operators like join, order by, filter by, and it makes use of both HDFS and MapReduce. Okay, so let's take a very quick look. Let's take a very quick look how Pig looks like to us. Okay, so in here you can see input equals to load big.txt as line. Okay, so even if you do not understand this script, do not panic. Okay, why? Because the way you learn a language is you look at the code, then you go back to concept, then again look at the code, go back to the concept. So you do a back and forth between the concept and the code. Okay, if you guys have heard about a book called the C programming language by Kernighan and Ritchie, KNR. So in that, they every time I look at the book, the idea which strikes me is that the way they taught was they showed a program, then they talked about theory, because theory is not interesting. Okay, but code is something which is very meaningful. Code conveys a lot of things as compared to the words. All right, so here what you see is we are saying input equals to load big.txt as line. So what exactly are we saying? We are saying load the data from HDFS from a file called big.txt and create a column. It's a single column data, and that column is line. And then iterate over record by record using for each. Okay, here we are saying iterate over record by record, break down the line into words, and then flatten, meaning convert one row into many rows such that every row contains one word. So it's a big single column table where the single column contains words, and then you group by word and then count over. After grouping you count it. Sounds good to you? So first we load and then we break down the line into words and then group the words and then count the number of values for each. Okay, now this is something very important. So what you see is there is left and there is right. On the left hand side we are creating a data set. On the right hand side there is an operation. So every operation is creating a data set. Okay, the data set is also called a relation. All right, and every row is also called tuple. if you have gone through tuple algebra in your education, then you will be very familiar with tuple and relation. Okay, so basically a table is a relation and the individual row is a tuple. Okay, all right. So this was this. Don't get scared if the objective was not to get you know not to scare you. Instead, the objective was to give you the overview. Okay. Now, what's happening here is up to this point, we will keep on uh, explaining, keep on creating these statement. Also, the lines with start with double dash are the commands. These are the code. This is a code, and this is also the code. Okay. All right. So now the same words which I was telling you, the Pig Latin is a data flow language. So I'm describing what to do with the data, and we are describing how is the data flowing. We are saying big.txt gets loaded here, then we iterate over it, then that gets stored here, and so on. We are describing how data flows, how data should be read, how data should be processed, and then we can store the result at various places. Okay? And it provides complex workflows, multiple inputs can be joined, and data is split into multiple streams. We'll go around with this same details again, okay, because these things would not make much sense right now theoretically. Okay, now here you what you see is here we can say instead of dump we could say store. Now the most important part we need to understand about this part is that Pig will understand this script and create map and reduce phases for you. Whatever we did earlier, Pig is going to do for you under the hood. Although it's not going to write the source code, it's basically directly create the jar and then execute the jar exactly the way we were trying to do. So Pig is basically your converter from Pig Latin to MapReduce. Okay. All right. So the usual comparison between Pig Latin and MapReduce. First, why would I code in MapReduce? Honestly, I would not code in MapReduce. I'll try my best to avoid it. I will instead use streaming if I'm forced to, because writing in Java is too much time consuming. It's not good for data scientists, and it's not great for any hacker. So if you get stuck with writing a lot of code and uploading it, downloading it subconsciously, it creates a mental block of trying out many things. Therefore it's very important to be able to churn data quickly in order to try things out. But if you are doing a larger development, then you go with MapReduce in Java properly. Okay, larger development as in you have your custom data sets, you are trying to create custom input formats and so on. Okay, and the performance is a very important issue. Even a single millisecond here and there is a very important issue. In those cases you go with your own custom MapReduce. All right, now so MapReduce does not provide you the operations like joining two data sets and grouping them and so on. Okay, while Pig Latin provides you those nice useful data oriented operations. Okay, Pig Latin provides you optimization such as rebalancing the reducers. So the way we were trying to guess the number of reducers, some of the work Pig Latin would try to do. Then Pig Latin will understand your script, do the error checking. Just the way SQL does the error checking. Say you are saying select star from a table where column 1 equals to something. Now column 1, if it doesn't exist in your table, it'll give an error, right? My Microsoft SQL or any SQL will give you an error immediately without executing. But if you're doing the same thing in your Java code, now your Java code when it runs, only then will be able to figure out whether that particular column exists in the table or not, right? and then the error would occur. So most of these error checking in the similar way is done in the pig Latin, and that helps you a lot. Now, when you have smaller code, then of course, there is a lower cost to write, maintain than compared to MapReduce. And the only problem with Pig Latin is it has got its limitations. It's great for standard data-oriented operations, just the way MySQL is, right? Just the way SQL is. SQL is great for data oriented works, but when you have to do something sequential or something which is out of the way, say you are writing a compression, your custom compression algorithm, in those cases, you may not want to do it in Pig or SQL. All right. The use cases of Pig are ETL as in extract, transform, and load. Do the research on data, iterative processing or batch processing. All right. And there are many more use cases, specifically whenever you are trying to do the research on data. Pig is something you can use. All right. The basic philosophy of Pig is it eats anything. The first pillar of Pig is it eats anything. The data could be relational, nested, or unstructured. Okay. Second is Pig live anywhere, meaning it's not only designed for Hadoop. Okay, the overall architecture is keeping in mind all kinds of environments where parallel processing is required. Then pigs are domestic animals, meaning they're controllable, they provide custom functions. If you have something which is not there already, you can quickly create one. Then pigs fly. Pig is designed for performance in the terms of they try to optimize a lot of work. Okay, you will see it provides a lot of knobs to control the optimization. All right, because Pig is just a client. Pig does not have a server. It's just a client which converts your Pig Latin, whatever script you will write, it'll convert it into MapReduce and schedule it on the cluster. Okay, so you don't have to install any server. All you need to do is extract Pig, download the zip, extract it, and start using it. Okay. First step would be you extract it and then set the Java home and run it like pig -x local. That will test whether your Java is working or not. Then you can add pig bin folder to path and run pig and enjoy the grunts. Okay. So here, uh, basically, you don't have to install in the production environment in case of Cloud Labs because it's already there and running fine. So you can simply open the console and start using Pig. Okay, most of the data has been uploaded into slash data in SDFS. You can start using it. Okay, now there is something called local mode. Okay, pig -x local mode. It runs without Hadoop installation and it's great for testing locally. It improves the development pace and you can use Pig for non-Hadoop processing. Okay, so in case you want to test it locally, you can use pig -x local. That's the command line argument for pig and get started. All right, so I would say that instead of talking too much, we'll just start. Okay, so basically guidelines to install is very straightforward. You can simply go here, basically from the pig releases page. Okay, and download the latest available. Generally the latest available is the one you should be using. Okay, and but most of our scripts are with respect to 0.13. Okay, we can test it out, no worries. Also, first let's just go through. Okay, it's very straightforward actually. You can just unzip it, put it in a folder and start using it. Okay, all it needs is Java home variable. That's it. Okay, Alright, so you can see this here. After logging in, you can simply say pig. And if you are not too big a fan of this kind of a console, what you can do is you can go to hue, hue and say go to pig here and write the script. Okay, and then once you're done, you can click on execute. Okay, right now we are on the command prompt. I personally prefer the command prompt. Why? Because it gives me I don't have to touch the mouse. Okay, so let's say the first one would be a equals to load. And one more thing, you can actually use pig to browse your HDFS very quickly. I said ls and it's showing me the HDFS my home folder. You see that? This is my home folder. And let's say there is a file called a. I want to see what is there inside a. So I can say cat a. Oh, there is nothing inside a. And or let's say yesterday we create our output was stored here. We could actually say ls. See that? It has shown us this. And we could say cd. So right now we are using, okay, now you can see that I was able to change the directory and we are interacting with the HDFS from inside the pig. So pig has an additional advantage, provide you these kind of commands using which you can talk to HDFS easily. So if you are tired of typing Hadoop FS, you could actually go into pig and start using this. Okay, so here you have this. Now you can simply say what was that, had this. So or you can I don't want to do a cat, yeah, because it's really, or you can say ls slash data and inside it you see pig, and if I say cat, this is all I'm talking to the HDFS. Okay, so if I'm trying to say a equals to load this file, I can simply load it. Okay, this is our first now we can say after I've loaded it into a, we can say dump a. Okay, is it working? Alright, it seems to be running the jobs. Alright, so it has loaded the data and printed it to me. Okay, so you must have noticed by now that it has actually started the job the way you start the job. Okay, it has actually started the job the way we start the job. Where are we loading the data? We are symbolically saying that a means this particular file. Okay, and a is just symbol, it's not really loading the data. Okay, a is just a kind of, we call it a relation. A represents this particular command internally. Okay, and when I say dump, only then it starts working. Before that it was just making notes. Alright, when we say a equals to load, it means pig took a note that you want a to be this particular file. Okay, it's not really doing anything. It does things when we say dump or say when we say dump or when we say store. Okay, so again it's a, you can start working on pig right away by using the pig command or using the hue. Alright, so there is something called local mode. We can run pig into local mode. If you have installed pig locally on your desktop or laptop, okay, you could run pig -x local and it will completely work fine. Okay, even if you don't have a Hadoop cluster, you can run things. And this time when I say ls, it will actually talk to my local files, not HDFS. You see, it's talking to my local files. Locally also I have A1 and B, so I can say A1, you see, and I can say A equals to load A1, and I could say dump A. See that? It has created a fake MapReduce. This is a fake MapReduce. Alright? I'll show you. This is a fake MapReduce. You remember our JUnit test cases yesterday which we discussed? That was a fake MapReduce done locally on your desktop. When I was saying test, it was actually running MapReduce. That MapReduce driver, it's the same MR unit which is used by Pig as well. Okay? It's the same MR unit. See here, I'm just trying to look at, there will be this mention of which MR unit we are using. Okay, see, it's a local job executor. All right. All right. So what I was trying to demonstrate to you is that even if you don't have Hadoop, you can start using Pig on your laptop after you download the Pig from their website and start the command prompt. But just that, keep a note of it that you have to execute it using pig minus x local. These are the arguments you have to provide to the pig commands. Okay. So in local mode, it talks to the local file system, and instead of, if you are running in non-local mode, then it talks to the HDFS. All right. Before going further into the pig script, we will let's talk about the command line argument. The first thing is, if you have written all the commands in a file, that becomes a pig script. Okay, so you can put all of your pig script into a file and then run pig space my script. Similarly, from the web interface, you can save the script and run it whenever you want to run. Okay, so this is how you generally do it in production. UI you hardly use, because here whatever you do from the command line can be automated and can become the part of the bigger project. Okay, so if you just want to execute pig to a single command and then exit, then you can say pig minus e and the command name. All right. Okay, the the basic construction of a pig program is that each processing step results in a new set, or in the typical vocabulary, it's called a relation. Okay, a set is also called a relation, except for dump and store. There are two commands called dump and store. Those basically are the one which generates the output. Most of the pig script is case insensitive, except for the functions, library functions, which are case sensitive. Library functions such as, we used a couple of functions earlier. As you will go forward, you will see that. So most of the pig-latin is case insensitive, and it also provides the multi-line commands just like C, C++, and Java and C Sharp. And the single line commands are similar to what you have for the SQL. So double dash means single line command. All right. So you can have here a very simple example. The first script is to convert this data into this. Let's compute the value of average, the what do you call NYSE dividends you have to find out average value of each of the item. So you have to find out average of CPO, average of CCS, and all that, right? So in case you were using the map reduce, what would you do is you will just in the map you will create this as the key, this is the value, and in the reducer all you will do is compute average, and that's it, right? Now here you can use SQL like commands, just that in SQL you do everything in a single statement. Here you break it down. Here you break it down into steps. So first thing is load. Let's look at this data first. Okay, let's take a look at this data. Where is this data? In the hue. In the hue, let's go to file browser. At the top level you have data, and there you see NYSE daily. There is a 3 MB file inside this folder. Okay, this is a 3 MB file, you see. So you could simply say load this, and here we are saying we are giving names to the columns. Okay, so we have said this. Now this finished very quickly. So basically it's not doing much, it's not doing anything, it's just making a note of what is the meaning of divs. That's the only thing it's noting down. It's not executing things right now. Okay, when you say dump or store, then it does something. Dump prints the data onto the screen, and store will store it in the HDFS. So you can see now it says that the input path does not exist. Why is it so say so? Is it because okay, let's just see why is it so. Okay, so can we just say something of this sort and then try divs again? Dump divs. Again, it says the same thing. It matches 0 files. Why is it so? Let's take a look at the hue. Oh, there is no such folder called dividends. There's only, okay, dividends, NYSE dividends. Okay, alright, there is a file actually. Let's just try to modify our statement a bit. Dump divs, will it work? Oh, wow, it says the path does. Oh, we are actually in the local mode. Okay, so here we go. Let's remove this asterisk because it's not a folder, it's a file. Alright. Had it been a folder here, instead of this file, had it been a folder, all the files in that folder will be loaded into a single relation or single set. See that? The process has now started, it is going to dump. So there is only, so since we are not doing much, we are basically loading data and printing it on the screen. And okay, so by default, when we say divs like this, there are many questions that arise. First, on what basis it's breaking the data? The quick answer is tab. Okay, and we are only saying 4 records here. Okay, so the rest are being ignored. So we can also go ahead and test. See, it's working fine. Now we have set dump and it has printed the data. Now we can say group by, and then we can execute group by. Then after this we are saying for each group by, and we can say averaged. Okay, so all of you must, the output directory already exists, so we'll have to create some other, let's say 6fab. Okay, now if you notice that the moment we said store, only then it is started the execution. Only then it's taking some time and doing something, right? Because when you say store, only then the map reduce job gets scheduled and get executed. Before that, it's basically noting whatever you say, it's noting the definitions and then doing the work. Okay? So that was about a quick another example of computing the averaged. Now you can see in Hue. Okay, let me go to my home folder. Here you can see, let me just sort it by the date. Okay, you can see average 6 fab. It has now, do you notice that the way it has stored is exactly the way MapReduce does. It created part something and then stored. See, so it has computed the average without you having to write the Java code. Okay, all we did was group by and then iterate and compute average, and that's it. All right, a little bit more about pig. We did not deal with numbers. If you see, here we loaded the data, right? We never specified what is the data type. It's a tab separated file, and we just loaded it just like that. And we computed average of the values. Now, that is something, a clever thing pig did. What pig did was, pig figured out that you are trying to compute the average, so that value must be a number. And therefore, it tried to cast those values into number and then do the computation. Here, okay? But it is important to know the data types. Although a lot of work, pig will do it for without any hassles, but still you need to know. So there are big data types: scalar, int, long, float, double, char array, byte array, date type. These are the data types pig provides. And basically, these data types are very much parallel to Java. Okay, so byte array means binary data. As some of you were asking, can it load JPG videos? It can. All right. Now, so other than the basic data types, pig provides complex data types such as map, tuple, and bag. Sometimes your individual column could be further a complex object, such as map. What is a map? Map is a collection of key value. Key can be only a string, while value can be further another complex object or the scalar. Okay, so you could have a column which in itself is a hash table, and further each value in that hash table could be further another hash table. So I mean, hash table might be a little bit alien to you, but let's just call it map. Map is a collection of key and values. Okay, whenever you have to have this kind of structure, you can use map. Okay, the format in which it expects the map data is in square brackets, and the key value pairs separated by comma and key and value separated by hash. Okay, in this format. All right, I'll show you a couple of examples of using the complex data type. Next is tuple. Sometimes each individual value could be like an array of other values. Okay, scalar is a simple primitive type of data, like integer, long, float, decimal, double, that kind of data. Okay, which is not complex. All right, and the other kind of data types are complex, which are composed or built of other scalar values. Okay, so a tuple is built of other scalar values. It's basically a fixed length ordered collection, like an array. Okay, where each value it's made up of multiple values, and each value could be a complex object. You can always think of tuple like a row in the database. Example of a tuple could be like this: string, integer, decimal, and then map. So you can see that it's made up of scalar as well as another map, and it expects the data to be in this format. The third complex types in pig is bag. Bag is an unordered collection of tuples, such as you can see that. So the analogy, you can think of bag as a database table. Bag is like a database table, and each individual row is like tuple. Okay, for you, map and bag might look similar. Okay, but don't worry, because map is composed of lot of key values, while bag is like a database table. All right, so you can see that the data format is in curly brackets and then the individual values. The most important part about bag is if the data is not fitting into the memory, it spills over to the disk. All right, so again, little bit more details about data types. Pig is not too specific, not too particular about schemas. You can either tell schemas upfront. For example, dividends equals to load NYSE, and we are telling that hey, there are four columns: exchange, symbol, date, and dividend. Exchange is a string which is character array, symbol is a string which is character array, and date is also a string, and dividend is a float. Okay, you can either tell pig that hey, my data has got this data type, or you leave it to pig to keep on guessing, to an extent that you may choose to skip even the column names. Up to here is a valid load statement. You could say dividend equals to load NYSE dividends. That's it. You don't need to specify anything. And individual columns, you could always refer using $1, $2, $3. Okay, I'll show you that part. All right. Now, similarly, while loading the data, you're describing the column type. You could explicitly say that my column name is A, or you could say A column map. Okay, meaning my data, which is the column called A, it is a map. Okay. Further, you can also go one step further, saying A is a map where where the values data type is a tuple, and the data type inside tuple is this much. So it's completely up to you to what level you want to describe the data type to pig. Otherwise, pig will do its best guesswork. Okay, by default it will load everything into like a byte array, and later on it tries to cast various values into what is needed. Okay, similarly, while loading the tuple, you could say my A column is a tuple, and further you could say this tuple has got two columns called X and Y, and you could go one more step further and say my tuple has got two columns X and Y. X is an integer, Y is a byte array, and so on. Right? Similarly, while describing something as a bag, you could say simply that hey, this is a bag, or you could go one step further and say A, my column is a bag where each individual tuple has got these columns. Okay, because what describes bag is what kind of tuple does it have, okay, and so on. Also, it's possible to cast data from one data type to another by putting kind of just like you do in C, C++, Java, by putting some data type inside round brackets. So if you want to cast A into some other data type, you could say bracket and int and A. Okay, so that was our little more detailed description. All right, now let's talk about load statement. The first load statement is load data. So by default, it will load the data, it will try to guess the data types. Tab is used as separator, and the URL could be either relative to your home folder in HDFS, or it could be absolute starting from the top level. Okay, and if you are running pig In local mode, every file you refer will be in the local file system. If you are running pig in non-local mode, that is connected to HDFS or Hadoop, okay, in that case you can simply read the data from HDFS. Okay, it will read all the files, it will dereference all the files to HDFS. Also, in case your data is not separated by tab, you could say load NYSE dividends using pig storage and then comma, which means it will think that the data is separated by comma. Alright, sometimes you have many files in a folder. You can use the wildcard character in case you have many dividend files, dividend 1, 2 and so on. You could simply say load NYSE dividend. Alright, similarly you can load data from HBase. Not only HDFS but also from HBase. Okay, you can load the data from other data sources. That's what we mean to say. So pig provides many kinds of storage. Okay, the default storage is pig storage, and the default pig storage, it expects the data, input data, to be tab separated. Okay, so also you can define the data type upfront, or you can leave it up to Hadoop to guess. Okay, sometimes you might want to load data from JSON file. In that case, you could use JSON loader to load the JSON into a set. Alright, now the little bit diagnostic tools. So a diagnostic tools like explain gives you the detailed analysis of query, like what is going to happen when I execute this, that is explain. And describe gives us the schema of a data set. Although there are many syntax highlighting tools, okay, such as Eclipse, Emacs, TextMate, Vim, everywhere there is a syntax highlighting. So you might want to use Pig's syntax highlighting tools. Alright, now let's move on to store and dump. Okay, store stores the data into a file or some other storage. Okay, store is just opposite of what load does. The example of syntax is this, where we are saying store a data set into this particular file using pig storage. Similar to that, there is dump. Dump basically prints the data onto the screen. It's useful for debugging, and it's useful for using the script that put the data onto the screen, and then you can redirect it to the files. So basically dump is only for printing the data onto the screen. You could the syntax is dump and the data set. All right, so now so far we have only talked about load and store. A little bit further, which is called for each. What does for each do? It takes an expression and applies that to every record. So you can say, in a way, for each is not like a loop. Instead, for each is more like a projection. It basically goes top to bottom on a data set for executing whatever expression you have given against every record. Okay, so that's what happens. So when we say for each divs generate this or that, what it does is it basically generate only two columns. So the syntax of for each includes generate keyword. So for each something, generate this or that. That kind of a syntax is what you have here. Okay, so you can parallelly try these. Okay, so let's say we want to pick up only two columns. Okay, if you want to pick up only two columns. Okay, All right, then we have this and dump values. So you can see that we will be only picking up two columns out of it. Okay, so what exactly we are saying, load this data from, load this particular HDFS file as four columns into divs, and then iterate over divs, generating only two columns, ticker and value instead of four, and then store this data into value one. But we are right now dumping it. Okay, you can see that it has printed only those two values. Okay, so if you want only two columns, then you can use this. All right, next is the syntax for each is further quite complex. I mean, the way you have select star, this and that in case of SQL. In the similar way, for each, let's say you have something called prices, which has so many columns. In case you want to compute close minus open, the value that you want to compute the differences between the two, you can simply compute, okay, like this, saying dump gain. So what we are saying? We are saying iterate over prices, generate the difference of close minus open for every record. It's going to generate a dataset called gain. It will contain only one column, and column will have the value equal to close minus open. Okay, now you can see that here, you can see it has computed the delta. All right, next is that in case you have not given the column names, okay, let's say you only had this much, then you could refer the individual values as from the positional parameters, positional references. Okay, you could say same thing like this and say dump gain 2. Okay, sometimes you want to generate only those columns which are basically all the columns before a particular value, all the columns before after a particular column, and so on. Let's say you want to generate all the columns up to open, meaning you want these four columns in the output. Okay, so all you do is for each prices generate dot dot open, meaning exchange symbol date and open. Okay, in case you are only looking for these four columns, open, high, low, close. In that case, you will use this kind of columns. Similarly, if you want to generate only these two columns, you could say volume dot dot. Okay, that means all columns after. All right. Now, there are a few questions I would like to ask you. Do you think this for each statement is having any reducer side code? Anybody? If you had to do the same thing in MapReduce, will you have a reducer at all? Yes, no? If we think about pig, what it's doing is it's basically generating map and reduce under the hood, right? So it's going to do exactly what you would do. So my question is, if you had to do the same thing as for each, will you have any reducer side code? Will you have any reducer? Answer is no. There is no reducer, only mapper. Why? Because for each does not do any grouping or sorting. There is no logic that requires all the values of a column to be gathered together. There's no need of reducer side code, only the mapper will do. Now, in the for each itself, there are quite a few syntax that we can use. The syntax is that if your data is complex, then also you can do for each. Let's say here is my data, and let's take a look at this data first. Okay, what does it have? And let's go to file browser, or we could simply say file browser. You can see this data here. Okay, you can see that this data is complex. First column, then tab, then second column, then tab, and then there is this. What do you call this? It's a bag. It's a bag of values. It contains two tuples. You can see that? It contains two tuples and it's a bag. And then there is a map here. So this is basically the baseball data where there's a name of the player, name of the team of the player, and then the attributes of the player, and then the past scores of the player. The total number of games he has played, how many times he was hit by the pitch, and on base percentage, grand slams how many, and so on. Okay, so this is a complex data because one field is of map type and other field is of bag type, and then you have these two strings. Okay, let's say you are only looking for, say, partial information out of it. Let's say you are only looking for batting average. How will you go about it? So where is the batting average? You can take a look here. The batting average is a part of this hash map. Okay, can you see that? So the fourth column we have to do the projection on and only pick up the batting average. Okay, so how do you do that? You say for each b ball, and in the whatever we have loaded just now, generate the name, which is the first column, bat, which is the which where is that? Yeah, which is the fourth column, and then we say bat hash batting average. So you can dereference the value for a key from a hash table using this kind of format. Okay, so now when I say dump avg, you will see that it has picked up only the batting average. You can see that it has figured out the batting average of all the. Basically, it has simplified the complex data, right? So you can do these kind of complex operation using for each. Let's say you only want to generate two columns out of a tuple. You can pick up only these two. Okay, you can basically say, let's say you want to change the values of tuple. You want to only keep the first column. In that case, you can say this things like this. You could say for each a generate, t is the name of the field, t dot x or t dot dollar zero. Okay, so zero based referencing. Similarly, while projecting a bag, you could use a similar way where you want to pick up a particular column. Similarly, if you have many columns in a bag, in a tuple, then you could simply say b dot x comma y. Then it will give us. It's a brief way of saying b dot x comma b dot y. Right. So that was a little the projection on the complex fields. Right. You can do the computation inside for each. Right. So while doing the projection means projecting one set of fields as some other set of fields. Okay, so while doing the projection, so you could load a file. Okay, after loading the file, you could say for each this generate dividends into 100 and give it a name, new column, a name called dividend, and also do something else. So you can do a lot of computation inside for each. Okay, you can do a lot of computation inside for each. If you want to see what kind of computation you could do, you can see here. There are many more functions. You have mathematical functions, you have string functions, you have datetime functions. For ETL, the one which will be very important for you is regex extract. If there is a field out of which you want to extract only some piece of information, for example, from this IP address, let's say I'm only going to pick up the port number, I can say regex extract and give a regular expression, and then refer to the tagged expression. Tagged expression means the one which is inside the brackets. Okay. Similarly, you could use regex extract, meaning you whatever brackets are found in your regex, for each bracket it will create one more column. Okay. So you could use regex extract all to convert your input data into fields. So there are many more functions you can try and use. All right. Now there are a few more things such as group by. What does group by do? Group by basically groups data on a field. It does not do the aggregation. It only groups the data. For example, if you have A in the form of two columns, like John 18, three columns, John 18 4, Mary 19 3.8, Bill 20 3.9, Joe 18 3.8. This is your A. If you group by on age, which is the second column, you can see the describe A saying it has got three columns: name, age, and GPA. Okay, so you are saying group A by age, which means it is going to create, the most important thing to notice is the fields which B will have. So group by will convert A into B. B will have two fields, group and A. The value of group is the column on which the data has been grouped, and the A is the name of the data set which has been grouped. Okay, so the newly generated data set contains two columns. First column name is group, group, that's final. Okay, second column name is the name of the tuple which has been grouped. Okay, and the value of the tuple, okay, the value here is a bag. It's a bag of tuples. It's a bag of those records which have been grouped together. You can see it clearly here. For 18, John and Joe have been grouped together, so it's inside one bag. Okay, the most important part to understand about group is the data structure of the input and output. All right, so that's a group by. So opposite of grouping is flatten, meaning given a grouped data, you can make multiple rows out of it. The way we did flatten, which you may not have noticed while we did the word count in the first example, there we've used flatten. So let's say we have Sandeep and we are given all the languages Sandeep knows. Then we have Arun, and then we have all the languages Arun knows. Then we have Simani, who and the languages he knows. And what do we want to do is we want to group this data based on programming languages. We are looking for how many people like C, how many people use C, how many people use C++, how many people use shell, and so on. So what we need to do is first we need to ungroup it. Okay, so we have to flatten it such that it will generate Sandeep C, Sandeep C++, Arun Shell, Arun C, C many Java, C many C++, and C many Lisp. Do you see that from input to output? Okay, all right. So we are saying flatten our data based on the second column called languages. Do you see that? All right. So that was the result of flattening. Now, afterwards, you can further, group it by, say, second column, say, group this data by languages and so on. All right. Now, filter. If you are looking for only few fields, if you are only looking for few fields, then you could use filter. sorry, not few fields, but few records. So let's say we are only looking for records which matches this particular regular expression. So we are saying filter divs by symbol that matches cm dot star. So what does it mean by cm dot star? What does this do? All the words that are starting with cm is what it's looking for. You see that? It means dot and then star. Okay, dot means any character, and asterisk means zero or more of the previous character, which is any character, meaning anything after cm, or maybe nothing after cm. So zero or more of any character is what it means. All right. Now sometimes you do not want certain fields. You might say filter my dataset by not this condition. You could apply not on any condition. Okay, as well as you could apply and or operators. These are called logical operators. We could say filter divs by, and then you could write the full condition saying this and this or this. Maybe you can combine with not as well. You can see the boolean operators. So you can write a boolean operator in this form. You could say a equals to this and so on. Alright, so basically using filter you can pick only few records out of many records. Alright, a quick question to all. Will there be any reducer when you say filter? There is no reducer generated because we are not doing any aggregation. So we don't require any kind of sorting, we don't require any kind of aggregation, so there won't be any reducer generated for filter. Alright? If you want to order your data set, you can simply use order by. You can say order my data set by a particular column, and you can order a data set based on multiple columns. You can say order divs by column A, comma B, and descending or ascending. In case you do not specify whether descending or ascending, it will assume that you are trying to order a field by a particular column in ascending order. So here it means that first order divs by symbol, and then order divs by first by symbol in ascending, and then if two records have the same symbol name, it will sort those based on dividends, that too in descending order. Okay. Now for distinct, what do we want to do is we want to find out only those records which are unique. So we can simply say distinct a particular data set, then it will only pick the tuples which are unique. The tuples which are identical, they will be removed. Alright, so a quick question to all. Will it generate any reducer code? The distinct part? Yes, there will be a reducer. Because to compute distinct, you need to order the data. Right? You need to order the data, and therefore you would need aggregation and you need to compute the distinct. Alright? Now the very important part, it is joining the two data set. You can simply join the two data sets using the join keyword. You could say join my data set based on this column with some other data set based on that column. So these are equi-joins whereby we want to basically bring all those records together for which the values are equal. Okay, so it will basically combine this tuple with this tuple where the symbol on both the sides are equal. All right. Now, sometimes you want to bring those records together from two data sets based on multiple fields, not on single fields. In those cases, you could say this. You could say join daily with divs based on these two fields, where these two fields are equal to this. So exchange and symbol from this, wherever matched with exchange and symbol divs 1, those two records will be brought together. Okay? You cannot have self join in pig. You will have to load the data twice and then do the joining. Okay? And in case if the two data sets have the common fields, you can refer them in this following manner. Okay? So this is how you do the joins. Alright, so go through the assignment for pig. With this knowledge, whatever you have today, you can solve those problems. Alright, so that's pretty much for today. We will continue this discussion on the next session. Please go through the assignment. Okay, make sure you finish this assignment, both quiz as well as the subjective one.